Okay, hello everyone. So we started with data structures with C programming, and we had first lecture where we discussed functions and different data types in C, then how to create a function, then we discussed about different data types, the inbuilt and user defined data types in which we did integers, characters, strings. We did not go much in detail, but we discussed like briefly what is percentage d, percentage f, percentage c, and percentage s. Then we also discussed how to create an array in C. How do you give the size to an array in C? And then we did also functions in C again. That functions has two arguments. One is the return type and one is the parameters that you pass. So we discussed that a function can return either an int or a car or a string, or if it is not returning anything, then it can be void as well. Void meaning it does not return anything. So this is a syntax basically of a function where you have a return type, function name, and then the parameters or the arguments that you are passing. It can also be created without passing any argument. So then this bracket is going to be an empty bracket. Then we also took one algorithm where we discussed how to print the maximum value in an array. So let's say you have an array of 10 digits and you want to print the maximum number, or vice versa, you have array of 10 digits and you want to print the minimum number, minimum digit. And the algo that we used was, we are comparing every element of an array to the first element, and in the comparison if we find that any other element is bigger than the first element, then we assign that bigger element as the first element. So in this way we are simply sorting, and then eventually we will be left with the maximum digit, the biggest number. And the same way you can do for the minimum, to find the minimum element. We discussed this. Then scope of a variable, that a variable can be locally defined or a globally defined. Globally meaning it can be used anywhere in the program between the functions. It can be used called in different functions, but if it is a local variable which is defined within a function, then it cannot be used outside of that function. Or if it is declared within a if else block or some other block of code, then it cannot go beyond that. Then we also discussed some string operations where we discussed string copy, string concatenation, string length, and string comparison. Constants, a value that cannot be changed. So if you define a constant and you give them a value, let's say 10, then in the whole program, the value of that constant cannot be changed, and we use the keyword const keyword. Then we discuss structures which are similar to classes, which is grouping of the same elements. So you create a structure and then how you call that structure, similar to a class or similar to a template basically. And the keyword in C is struct. This is grouping of the similar kind of elements. So today we will continue with the pointers. So basically, what are pointers? Pointers are variables, but they hold the memory addresses. Instead of holding the value, the actual value, they hold the address of that value. So they point to a particular, let's say you declare a pointer which is pointing to a value 5. So it is pointing to a value 5, but the actual storage is the memory address of where that particular variable 5 is stored in memory. So we can understand that using a using an example. So whenever you are pointing to a variable, that value can be accessed using this asterisk keyword. And whenever you want the address of that value, the actual address that pointer is storing, then you can use the ampersand operator. If you want to modify the value of the variable, then you can simply say star ptr 127, and that would modify the variable. Now let's look at this program. What is happening here? We are creating two variables, int var1 and var2. Then we are declaring a pointer ptr, and we are assigning a value to var1 which is 5. So var1 is 5. Then we are assigning the address of var1 to ptr. Now when we assign the address, because ptr is basically a pointer, so pointer will only accept the memory addresses. When you assign memory address to a pointer, then automatically that pointer is pointing to the value stored in var1. If var1 is 5, then here ptr is also pointing to 5. And then we are creating another variable var2, and we are saying ptr pointer is pointing to whichever value, that value should be assigned to var2. So var2 becomes also 5. var2 also becomes 5. var1 is 5. Now we are changing the value that ptr is pointing to 7. Because we changed the ptr is pointing to 7, now var2 will also be pointing to 7. var2 will also contain 7. However, var1 is only 5, so var2 has changed and var2 is containing 7, and var1 is only is 5. So ptr basically contains the memory address. Now let's create an array of 6 elements, and we are initializing the array and giving the elements there: 2, 3, 5, 7, 11, 13. And we are then declaring another integer x, and we are declaring two pointers. Pointer declaration is by the data type, then star or asterisk, and then ptra or ptrb, or you can give any name you like. This is basically an integer point declaration. Integer pointer declaration. Pointer is of int data type, meaning it will point to the values which are of integer in nature. You can have a car pointer, and so on and so forth. Now this array, the elements are 2, 3, 5, 7, 11, and 13. Okay, then you have an x also, and then you have ptra and ptrb, and we have memory addresses here, and we also have the values written here, the values that the pointer will be pointing to. Now we also have memory address of PTRA, which is 1028, and memory address of PTRB, which is 1032. Memory address of X 1024, so on. Now how to point to an array element? PTRA is equal to ARR. When we say, what is ARR? ARR is the name of our ARR is the name of our array. When we are saying that PTRA is equal to ARR, what does that mean? PTRA is equal to ARR, it is going to point automatically to the first element in the array, and the first element in the array is 2, and therefore this is line going from PTRA is pointing to 2. PTRB is ampersand ARR 5, so ARR 5 meaning ARR 5. So PTRB stores the memory address of ARR5, stores the memory address of ARR5. PTRA stores the memory address of ARR0. Okay, so PTRA is pointing to 2, storing 1000. PTRB is pointing to element 5, sorry, element 6, but index position 5, pointing to storing 1020 memory address. How do we do pointer incrementation and decrementation? So when you do ptra plus plus, what will happen? It will now point instead of first element to the second element. So arr 1 it's gonna point, and ptrb minus minus it's gonna point, it was pointing to the last element, it is now going to point to the second last element. Okay, and so their subsequent memory addresses will also change. So note here, ptra is pointing to arr1, so 1004 is stored. ptrb is pointing to fourth element, 11 memory, fourth element having 11 value, its memory address is changed to 1016. So this is how we can do incrementation and decrementation. We can even do addition and subtraction with the pointers. If you say ptrb is equal to ptrb minus 4, what is the value that ptrb is pointing to? ptrb is pointing to, what was the value that ptrb is pointing to? ptrb here is pointing to 11, right? So 11 minus 4 is gonna be, 11 minus 4 is going to be 2. Sorry, 11, not 11 minus 4. Yes, 11 minus. What basically it means, not the actual subtraction but the number of steps. So अगर 11 है तो ये क्या करेगा, माइनस 4 कर देगा, तो 1 2 3 4, और ये 2 को पॉइंट करने लग जाएगा. अगर आपका पास पीटीआर बी है और आप उसको +5 कर दो, तो पीटीआर बी किधर है? पीटीआर बी क्या पॉइंट कर रहा है? पीटीआर बी आपका पॉइंट कर रहा है, पीटीआर ए, सॉरी, पीटीआर ए आपका पॉइंट किधर कर रहा था? यहाँ देखते हैं, पीटीआर ए जो था वो हमारा 3 को पॉइंट कर रहा था. ठीक है, पीटीआर ए 3 को पॉइंट कर रहा था. अब हमने यहाँ पर कर दिया +5, तो 1 2 3 4 5. तो पीटीआर ए अब आपका किधर पॉइंट करने लग जाएगा? पीटीआर ए अब आपका किधर पॉइंट करने लग जाएगा? 13 में. ठीक है, पहले वो किधर पॉइंट कर रहा था? वो 2 को पॉइंट कर रहा था, 2 को पॉइंट कर रहा था, तो 1 2 3 4 5 13, 2 को पॉइंट कर रहा था पीटीआर ए, +5 कर दिया तो 1 2 3 4 5, अब 13 को पॉइंट कर रहा है. पीटीआर बी जो है, पीटीआर बी, पीटीआर ए, पीटीआर बी जो था वो आपका, पीटीआर बी जो था वो आपका 11 को पॉइंट कर रहा था, इधर था. आपने -4 कर दिया तो 1 2 3 4, तो वो अब 2 को पॉइंट करने लग गया. तो बेसिकली दिस इज डिस्टेंस बिटवीन ए एंड बी. x इज इक्वल टू पी टी आर ए माइनस पी टी आर बी. तो पी टी आर ए जो है अभी आपका किधर है? ए जो है वो आपका 13 पर है, बी जो है वो आपका 2 पर है. दोनों के बीच का जो डिस्टेंस है वो कितना है? 1 2 3 4 एंड 5. So that distance between this and this, the distance is 2 3 4 5, and that 5 is stored in your x. Okay, two ways to access an element in C: array indexing and use of pointers. Now see what is happening here. ARR3 is 1012 and the element is 7. So ARR3, the memory is 1012, the actual value, and it is pointing to 7, right? Or we could say you use pointers. So ptrb plus 3, what is ptrb plus 3? ptrb is where? Plus 3, 1 2 3, and then it's gonna be 7. Okay, so these were something little bit about pointers. So basically, to summarize, pointers store the memory addresses of the variables, and it points to the to the variables, but it stores the memory addresses. If you want to access the variable, the actual variable, you have to use the star. If you want to access the address of that variable, then you have to use the ampersand. If you want to assign again any value to a pointer, then you have to use star. If you want to assign memory address, you use the asterisk. Okay, this is as simple as that. You can increment or decrement a pointer. You can also add or subtract a pointer. You can also find the distance between two pointers. You can manipulate an array either by the index positions, or you can manipulate an array using a pointer. For example, here two things: array 333, arr3 will give the third element or the fourth element, because starting position is index position is 0, it's going to give you the fourth element, which is 7. Or you can use another way, ptrb plus 3, where, and of course star means the value that the pointer is pointing. If you use ampersand, it's going to give you the address. So ptrb plus 3, so ptrb plus 3, 1 2 3, so it's going to give you it is star, so it is going to give you 7. Okay, now here we are creating uh, an array of characters size 100. Then we are creating a character pointer. Then we are asking the user to input a string, and we are using getS to get the string. Now we go through the each element of the string using a for loop, and we are checking if the element is the lowercase character. So if the pointer is pointing to A or Z, then we say if it is greater than or equal to A, or less than or equal to Z, because it is a character pointer, right? We are saying convert the element to uppercase. We are converting it to the uppercase A, and then we are incrementing the pointer. In the second block here, we are finding the length of the string, and then we are printing the length of the string. In another program, here we are declaring an array. So there we just declared an array. We did not assign any values to it, right? It was just an array of 100 elements, 100 size. Here we are declaring an array, character array, and then we are giving it some a string. Okay, another array, then string. Then we are declaring two pointers, and we are declaring another array. Then what we are doing basically here, while the pointer is not 0, is not equal to 0, pointer is not pointing to the end of line. What we are basically doing, if the pointer is not equal to O and Q is not pointing to A, then you assign whatever P is pointing to CH, right here, another character to CH. Now what P is pointing to, S meaning, so it is at the starting of 2, so it's gonna be here, right? To be or not to be, so CH becomes to be or not to be. And then whatever is in the Q, you assign that to P. Now P becomes ya ba da ba do, right? And then CH becomes, so this is basically interchanging the two pointers, whatever they are pointing to. So CH will become to be or to not to be. So P is pointing to, pointer P is pointing to be or not to be. Pointer Q is pointing to yaba daba do. We are interchanging it. So this is like a temporary holder, where we are pointing, this temporary holder points contains what pointer P is pointing to, so to be or not to be. Then we changes the content that p is pointing to yaba daba do, and then we change the ch to q. Okay, p plus plus q plus plus. Now the strings have interchanged, right? Now s has become what? Yaba daba do, and q and d has become to be or not to be. So that is it. And then we will continue with in the next class we will continue with dynamic memory allocation. Dynamic memory allocation.